In this video, we will discuss about phase shift oscillator or PSO. As we have discussed in the previous video about different types of oscillator, phase shift oscillator is a sinusoidal oscillator and it is a RC oscillator. In this oscillator, we use resistors and capacitors. And in this video, we will discuss some examination questions on phase shift oscillator. You have a long question like this. With the help of a circuit diagram, explain the operation of a phase shift oscillator. Write the expression for the frequency of oscillation and the condition for sustained oscillation. This is the circuit diagram for the PNP common emitter transistor RC phase shift oscillator. This is your PNP transistor and these are the three RC circuit. This is one RC circuit. This is another RC. This is the third RC. So in this RC phase shift oscillator, you have three RC circuits, and this is your PNP transistor, and here you have two resistors R1 and R2. I have discussed about this resistor R1 and R2, which is basically used for the transistor biasing and stabilization. R1, R2, RE and CE, all these are used for the transistor biasing and transistor stabilization. The transistor it is in common emitter configuration. You see this is the emitter which is common to base, and this emitter is also common to the collector. So this transistor is in common emitter configuration, and about this R1, R2, RE and CE, you watch my previous video about transistor biasing and transistor stabilization, why Q point is necessary in case of transistor, or operating point is necessary. I have discussed it in the transistor biasing and transistor stabilization circuits. But here we will discuss about the phase shift oscillator, that is the PNP common emitter transistor RC phase shift oscillator. And what is the basic principle in phase shift oscillator? As you know, the RC circuit, each RC circuit give a phase difference of 60 degree. So you have three RC circuits. So here you will get a phase difference of 60 degree. Here also you have a phase difference of 60 degree. Here also you have a phase difference of 60 degrees. So total RC circuit, if you have three RC circuit, they will give a phase difference of 180 degree. And as you know, in case of a transistor, then the transistor produces a phase difference of 180 degree. Between the input and output, you have a phase difference of 180 degree. That means the phase difference of input voltage and output voltage. The difference of phase between the output and input, this is equal to 180 degree, and the phase difference in this RC circuit also 180 degree. So total phase difference or phase shift around this loop, that is this is your loop, that means positive feedback loop. The phase difference is again given to the input. That means there is a net phase shift of around 0 degree or 360 degree, and that we need in case of the positive feedback. That is why we use the RC circuits. And why there is a phase shift of 60 degree in one RC circuit? Because during charging of capacitor, there is a phase difference of 90 degree between the voltage and current. As I have discussed in case of the capacitor, that if you have a circuit containing resistor and capacitor, and if you represent the voltage as V equal to Vm, suppose sin omega t, then the current will be equal to Im sin omega t plus pi by 2. That means during charging of capacitor, there is a phase difference of 90 degree between the voltage and current. That is when the capacitor gets charged, the current is ahead by 90 degree flowing through the resistor in the RC circuit. So if you use two RC units, then what will be the phase shift? The phase shift will be 180 degree. But if you use 3 RC units, then what will be the phase shift? The phase shift in total phase shift also will be equal to 180 degree. But in each RC, the phase shift will be equal to 60 degree. So this is the physics why you use RC circuit. Okay, because in capacitor, when the capacitor gets charged, then the current what you give to the resistor, that will lead the voltage by pi by 2. So if you have two RC circuit, you minimum require two RC circuit, because in two RC circuit you can introduce a phase shift of 180 degree, is not it? And if you use 3, then in each RC you have a phase shift of 60 degree. So this is the basic physics of the phase shift oscillator or PSO, where you introduce a net phase shift of around the loop 360 degree, 180 degree due to the transistor, and 180 degree due to the 3 RC circuits. Then what is the frequency of oscillation? From the condition for sustained oscillation, we have discussed it in the previous video. The condition for sustained oscillation, A into beta equal to 1. A is the gain of the amplifier without feedback, and beta is the feedback fraction, and this is called the condition for sustained oscillation. And from this condition you can deduce the expression for the frequency of oscillation produced by the RC oscillator or RC phase shift oscillator, and the frequency of oscillation is given by f equal to 1 by twice pi RC square root of 2n. You should remember this formula, where f is the output frequency taken in hertz, R is the feedback resistance in ohm, C is the feedback capacitance in farad, and n is the number of RC feedback stages. If you take 3 number of RC feedback stages, then this will be equal to 3 into 2, 6. So you will have root 6. Is not it? So the frequency of oscillation for 3 RC stages will be equal to 1 divided by twice pi RC square root of 6, or 1 by square root of 6. Square root of 6 in the denominator. And this formula you have to remember, because problem will come from this formula. Then you have also a question attached to this long question, or it may be a separate question. Discuss the advantages, disadvantages and uses of phase shift oscillator. As we know, phase shift oscillator produces low frequency. It is useful for low frequency. So this is the advantage of phase shift oscillator. And phase shift oscillator have good frequency stability, and there is no requirement of inductors or transformers in RC phase shift oscillator, because here in phase shift oscillator we use resistors and capacitors, so there is no use of inductors and transformers. And what are the disadvantages of phase shift oscillator? It is not suitable for high frequency oscillation, and in phase shift oscillator the feedback is very small feedback. That is why the output is also small. And what are the uses of phase shift oscillator? It is used in audio oscillator, and it is also used in musical instruments. Phase shift oscillators are used in GPS units, and phase shift oscillators are used in for the production of sinusoidal wave generation. Sine wave generation can be, we can use, we can generate sine wave by the help of phase shift oscillator. Then you will have short questions from phase shift oscillator like this. Phase shift oscillators are commonly used in dash range. I have told you phase shift oscillators are commonly used in low frequency oscillation. So it is used in audio frequency range. As we know, the audio frequency range is from few hertz to 20 kilohertz. So phase shift oscillators are used in audio frequency range. You have to remember it. And another question, pure sine wave output is possible in case of which oscillator? In phase shift oscillator, pure sine wave output is possible. And another question, dash oscillator circuit can be used to produce very low frequency. As I have discussed it, phase shift oscillator circuits are used to produce very low frequency. Phase shift oscillator cannot be used for high frequency. For low frequency generation, we use phase shift oscillator. A phase shift oscillator provides dash stabilization. Frequency stabilization can be obtained by using phase shift oscillator, but better frequency stabilization can be done by other oscillators, but it can sometimes also use phase shift oscillator for frequency stabilization. So this is a brief discussion about phase shift oscillator. Such type of questions will come in the examination, and in the next video we will discuss more about the oscillators. Thank you.